Hello and howdy and welcome back. We're taking a look at question number 17 on the 2002 Pascal contest. Okay, hopefully you've had a chance to take a look at it. If not, as always, you can go to the link in the description for the video and you can get a copy of this contest as well as all the other Pascal contests put out by the University of Waterloo. So question 17, the number 1000 can be written as the product of two positive integers, neither of which contain zeros. The sum of these two integers is... Alright, so we've got 1000 and we're breaking it up as a product of two positive integers. So, one thing we could try and do is list out all possible ways to write down 1000 as a product of two positive integers. Okay? That's something we could certainly do. So we could have 1001, and we could have 502. Some of these have zeros in them. 250 and 4, and so on. And I could make a list here, but I'd have to wonder, how do I know if I've got every possible product on there? It's a good question. I don't really need to know that, absolutely. As long as I can go through and I could just by chance work out the two factors that they want, I'd be all set. I could just add them up. But maybe I want to go through this in a very logical, very efficient fashion. And I want to make sure that I have written out all possible products. What I want to do is I want to make sure I've got them all. Well, how can we determine how many possible pairs of factors a number has? How many factors does a number have? And to answer that sort of question, we have to use what's called a prime factorization. So if we want to list out all the numbers really nice and neatly, we should break down 1000 into its prime factorization. And what that is, if you've never seen it before, is we write 1000 as a product of powers of prime numbers. So we see the number 2 goes into 1000. So 2 is definitely going to be in here. And let's work out all the prime factors of 1000 first. So I notice 2 goes into 1000 and I get 500. Another 2 could go in there. I get 250. That's got another factor of 2. And we get 125. Hey, that's a factor that doesn't have a 0. But we'll come back to that. 5 here. 125 is 5 cubed, so we'll get 25 here. And then we get another 5. So we can write 1000 as 2 to the power of 3, 5 to the power of 3. And every factor of 1000 looks like 2 to the p, 5 to the q, where p is between 0 and 3, and q is between 0 and 3. So we'll flip over to the next page, and we'll talk a little bit more about this. So we'll just repeat, 1000 has a prime decomposition, or a prime factorization, 2 to the power of 3, 5 to the power of 3. Every factor of 1000 looks like 2 to the p, 5 to the q, for some integers p and q in this range. Okay. So for example, 250, that's going to look like 2 to the 1, 5 to the 3. Another example would be 4. That's going to look like 2 to the 2, 5 to the 0. Now, if I want to ensure that my factors, which have to all look like this, 2 to the p, 5 to the q, have no zeros, well, they can't have zeros anywhere, but they especially can't have zeros at the end. So to have a factor with no zeros, means you can't be a multiple of 10. All multiples of 10 end in 0. Well, what would being a multiple of 10 look like? You'd have to have, so to be a multiple of 10, you must have a factor of 2. So that means p is greater than or equal to 1, and a factor of 5. That means q is greater than 1. So if that's what it takes to be a multiple of 10, to not be a multiple of 10, we have one of p equals 0 or q equals 0. And we need two factors that aren't multiples of 10. So two factors where, maybe both of them have p equals 0, or both of them have q equals 0, or one has p equals 0 and one has q equals 0. So I'm going to give my factors names. So a and b are going to be factors of 1,000 without zeros, so that a times b is 1,000. So these will be exactly the factors that we're talking about in this question. And I'll say that a looks like 2 to the p, 5 to the q, and b looks like 2 to the r, 5 to the s. So one thing I can note is that a times b has got to be 1,000. But that's 2 to the p, 5 to the q, 2 to the r, 5 to the s, and that's going to be 2 to the p plus r, 5 to the q plus s, and that's got to be 2 to the 3, 5 to the 3. So by comparing exponents, we know 3 is going to be p plus r, and 3 is also going to be q plus s. Now, a is not a multiple of 10, so let's just take a guess. Maybe p is equal to 0. Then r has to be 3 minus p, 3 minus 0, which is 3. So b has a factor of 2. So b must not have a factor of 5. Otherwise, if it did, it'd be a multiple of 10, and it'd have a 0 at the end. So that tells me s has got to be 0. But then q is 3 minus s, which is 3 minus 0, which is 3. So that tells me a is 2 to the 0, 5 to the 3, and b is 2 to the 3, 5 to the 0. Well, that's just 125 and 8. And look at that, we have two factors that don't have any zeros in them. They're certainly not multiples of 10, and when we work them out, we see that they don't have zeros anywhere else. Now, you might be thinking, well, that took you a long time, and you already ran across the number 125 way back when you were working out the prime factorization of 1,000. And you're absolutely right. And so if we'd realized that, which we sort of did, if we'd realized, 125 has no factor of 0, maybe the other half, the remaining factor, 8, also doesn't have a 0. Aha, we're done. You certainly could have done that if you'd realized that. Time is of the essence when you're doing these competitions. You only have an hour. And whatever you can do to speed up the process, and if you just stumble across the right answer, then that's great. Go with it. But we stumbled across that answer. We came across 125, and we might have said, well, what's the other part of this? Where's the rest of the 1,000 going? 1,000 over 125 is 8. Then we could have figured that out. But we stumbled across the 125. What we've done since is we took a look at it and said, okay, well, if I don't want a 0, what does my prime factorization of my factors have to look like? And we were able to very logically, and I'd say still very quickly, work out what A and B, these two factors, had to be. And we didn't have to stumble across anything. Okay, so if this were a written contest, we'd actually have an explanation done. And if this were a question where, we were doing our calculations and we didn't stumble across that 125 or didn't stumble across 8, we still have a plan of attack. We have a method for going about this, and that's part of what I want to get across in this solution. So yeah, if you stumble across things, fantastic. But if not, it's a good idea to see in solutions how we might go about actually trying to work out these factors in a logical and mathematical and calculating manner. And that's what we've got here. So, however you got your answer of 125 and 8, we are asked for the sum of these two integers. A plus B is 125 plus 8, and that's going to be 133. And that's an answer of C. So that finishes up question number 17. In the next video, we're going to go through question number 18. And I'll see you guys then.